All right, let's look at the homework 3.8, problem number 3. All right, so let's look at part A. All right, so we want to find the mass that remains after t years. All right, so let's see. Initially, we have 50 milligram, so y of 0 is probably 50. All right, so let's check the answer. All right, I came back and it looks like we got step 1 correctly. Step 2, since the half-life is 30 years, y of 30 is going to be half of the original amount. So it's going to be 25, right? So let's check the answer. All right, I came back and looks like we got step 2 correctly here. All right, so we're using, let's see, 25, so that's a half of the original amount. And then this is after 30 years, so they put the 30. And we want to solve for, so divide through by 50. So 25 over 50 would be 1/2, right? And so therefore, k is going to be, right, so we need to solve for k. So we take the natural log of both sides. So you're going to get 30k is equal to natural log of 1/2, right? And so that's 30k. So we take the natural log here, take the natural log there. So you get the natural log and e cancel out. So you have a 30k. So we're going to have to divide this guy by 30. All right. So let's check the answer. All right. I came back and looks like we got step 3 correctly. Let's look at step 4. All right. So let's see, we have, so we're talking about just log properties here. All right, so here we have 50, so we put 50 here. All right, so I'm going to apply e to the natural log of 2. So that will give you just 2. And raise it to the, right, so natural log of 2 and e gives you 2. But there's a negative sign, so it's going to be a negative t over 30. Right? So we don't really need the parentheses there, so we have that. All right, so let's check the answer. All right, I came back and it looks like we got the step 4 correctly. All right, and let's look at part B. All right, how much of the sample remains after 40 years? So all you really have to do is plug in 40 into this formula here. All right, so let's do that. All right, so when you plug in 40 here, so you have a negative 40 over 30. So it's going to be negative 4 over 3. You can just divide top and bottom by 10. So we have that. Then we're going to just compute this using a calculator because we have to round the answer to 2 decimal places. So it's going to be 50 times 2 to the negative 4 over 3. Right, then hit enter. Right, so it's going to be 19.84. So I'm going to type in 19.84. Right, so let's check the answer. All right, I came back and looks like we got part B correctly here. All right, so let's look at the part C. After how long will only 1 milligram remain? All right, so we have a formula. All right, so the formula, actually I have to look that up, and the formula was, right, so if you go here, right, so it's y of t is equal to 50 times 2 to the negative t over 30, right? So y of t is equal to 50 times 2 to the negative t over 30. All right, so we want this to become 1 milligram. All right, so let's solve for this. So I'm going to get rid of 50 first, divide through by 50. So you have a 2 to the negative t over 30 is equal to 1 over 50. All right, then we can take the natural log of both sides. So I'm going to put a natural log here and a natural log here. Then you can bring this negative t over 30 in front. So this is going to give you negative t over 30 natural log of 2 is equal to natural log of 1 over 50. All right, then we just need to isolate t, so we're going to just multiply, let's see, multiply both sides by negative 30. And also divide through by natural log of 2. All right, so you're going to get t is all by itself. Then we're going to multiply by negative 30, so natural log of 1 over 50, divided by natural log of 2. All right, and one thing we can do is actually, let me look at what they want. All right, so here, all right, so we want the negative 30 in front. So they actually want log to the base 2. So we have to do a change of base formula here. So this is going to be negative 30. Right, so negative 30 is sitting right here. All right, so you have a natural log of 1 over 50 over natural log of 2 is log to the base 2, so which is on the bottom here, of 1 over 50. All right, so let's type it in. All right, it's a 30, so it's going to be 1 over 50. All right, so let's check the answer. All right, I came back and looks like we got step 1 correctly. And in step 2, we just have to compute this. Actually, we're going back to natural log. It's a 1 over 50. And then you have a natural log of 2 on the bottom. So I'm going to just bring out a calculator here. And let's compute it. So actually, I'm going to just put the view always in front. All right, so we're going to have, it's going to be negative 30. All right, then you're going to have multiply by natural log of 1 over 50. 1 over 50. And then divided by natural log of 2. All right, then hit enter. All right, so 1 decimal places, so it's going to be 169.3. All right, so 169.3 years to become only 1 milligram. All right, so let's check the answer. All right, I came back and looks like we got the part C correctly. All right, that's it. I hope that this was clear.